This question most of the time asked in examination, how will you represent graphically elevation boiling point of the solution? So we have the topic graphical representation of elevation in boiling point of solution. Elevation in boiling point of solution. So just see, very very simple. If we have this one, so we have this kind of graph here. Physical chemistry is the branch of science, I have told you, deals with the study of any phenomena with extensive use of graph and mathematical form. So you have to draw graph for each and every event here. So in x-axis we have temperature. Okay, it is we have temperature. In y-axis we have vapor pressure. Why vapor pressure? Because we are talking about elevation boiling point, and boiling point is what? It is the temperature at which vapor pressure becomes equal to the atmospheric pressure. So that's why we have considered vapor pressure here. अब suppose initially this is 0 point, so at room temperature is never 0. Say it is initially 20 degrees Celsius. Say this is the point at room temperature, and this is the line, and this is 0, 100, 200, 300, 400, 500, 600, 700 and 760. So this is the point at which pressure is 760 mm of Hg. You have any solvent having initial temperature is 20 degrees Celsius. If we increase the temperature, vapor pressure will rise. Initially it is less, and at a particular time this becomes 760. After this point this becomes parallel to y-axis, this line. So draw perpendicular on x-axis. This is the point. Say this graph is for solvent. So solvent, so this is the increase in vapor pressure. As the vapor pressure reaches 760, this becomes parallel to y-axis, and draw the perpendicular. So it is called T naught. It is the boiling point of the solvent. So when solute is added to this solvent, this becomes solution. Say this is the graph for solution. At 760, this also becomes parallel. So draw the perpendicular on this. Say this is the line for solution, and this is the point at which this cut on x-axis. This is TB. So this is T naught. This is T naught, and this is TB. So this and this, डिफरेंस ऑफ दिस एंड दिस, ये इस पूरे में से ये माइनस कर दो तो आपको ये इंक्रीज मिल जाएगा. दिस इज कॉल्ड डेल्टा टीबी विच इज कॉल्ड हियर एलिवेशन इन बॉइलिंग पॉइंट. एलिवेशन इन बॉइलिंग पॉइंट एंड इट इज TB माइनस T नॉट. सॉल्वेंट की लाइन पहले बनाएंगे तो ये T नॉट की वैल्यू स्मॉल है और आगे गए तो TB मिला. इस पूरे में से इतने में से इतना माइनस कर दें अगर आप, तो यू विल गेट द डिफरेंस, एंड दिस डिफरेंस इज कॉल्ड हियर एलिवेशन इन बॉइलिंग पॉइंट. अगर अब किसी कोई प्रॉब्लम है तो मुझे बताइए. ग्राफ समझ में आगे बेटे सबको? यस. इज देयर एनी प्रॉब्लम इन द ग्राफ?
Yes, sir.
Any problem? Yes, any problem?
No, sir.
Okay, note down this graph. Okay, note down this graph. फट जाएगा ना, ज़्यादा मत कर. छोटा कर देते हैं ये, वहीं उसके साथ साथ रहते ना बेटे दोनों. ये ही होता और इसका नीचे रख देते, सबसे बढ़िया रहता. दूर करके इसकी विजिबिलिटी कम कर दें. Yes. Now look here. So after this article, we have the following note points. N dot B. N dot B means note point, nota boni. This is the Greek notations, which means note point. That is the important point of the topic. First point, first formula आपका था small m is equal to 1000 kb small w over del tb capital W. यहाँ पर small m का मतलब था, here small m means molecular weight of non-volatile solute. Don't forget this one, volatile solute. The second formula, del Tb is equal to small m into Kb, where this small m means molality. So don't get confused. These are the two different m. If in this formula small m, it is molecular weight. In this formula small m, it is molality. So don't get confused in these two small m. And number third one, what is Kb? What is Kb? Kb is what? So Kb is called molal. We have defined already. Molal elevation constant. It is molal elevation constant. Its another name is gram molecular elevation constant. Elevation constant. Its another name is ableoscopic constant. Ableoscopic constant. Sometimes we have question, define molar elevation constant. So whenever there is a definition of any constant, how can we define? First we write the formula. Since del Tb is equal to small m into Kb, equation number 1, let molality is equal to 1. So this formula becomes del Tb is equal to 1 into Kb. Equation number 2. It means molar elevation constant is equal to elevation in boiling point of that solution having molality is 1. So this is the definition. Kb is equal to del Tb because 1 into Kb is Kb. So, but 1 when? This is when molality is 1. It means a solution having molality is 1, having elevation in boiling point is equal to its Kb. So this is the point from where we will write the definition of Kb. Please note down these 3 points. Yes, have you noted down?
Yes, sir.
Okay.
Yes, sir.
Now write the definition.
Yes, sir.
Okay, write definition below that. Mathematically, molar elevation constant is equal to the elevation in boiling point of the solution is equal to elevation in boiling point of the solution, elevation in boiling point of the solution having molality is 1 mole per kg. Having molality is 1 mole per kg. This is the definition of ableoscopic constant. Ableoscopic constant.